Good morning children. Today we are going to perform question number 1 from the question paper ISC question paper 2019. It is an experiment of optics. We have to use a lens and 2 pins to perform this experiment. So let me first look at the question paper. We'll go through the question paper, and my first instruction for a student is that always have a pencil in your hand and underline all those points which they are asking you to record in the copy. So first let us see the question paper. So children, this is question number 1 of question paper 2019, and in the question paper you are given first the instructions. You can pause the video and can go through the instructions. Procedure of the experiment, ray diagram, circuit diagram and precautions are not to be written in your booklet. That means you don't have to draw ray diagram, you don't have to copy the question paper. If circuit diagram is there, then you don't have to copy it, and precautions also, if there, you don't have to write it in the question answer booklet. Then you are given 2 questions in each paper, one of optics and one of electricity. So you are supposed to spend 1.5 hours on each question. That means you have to complete your first question in 1.5 hours. Then they have given you this apparatus you have to use. The object also you are not supposed to write in your copy, but the object is to determine the focal length of the given convex lens. The given convex lens will be given to you in the lab by no parallax method. 2 pins, 1 convex lens, a holder to hold the lens and holder to hold the pins, and an optical bench. Then I'll explain you, as I already explained in one of the experiments, how to remove parallax. I'm just reading, go through the lesson, go through the instruction that they are saying arrange object pin, image pin and lens on the optical bench as shown in the diagram, and adjust the height of the object pin, lens and image pin such that at least here I'll suggest that use your common sense beta. This is the observer, that means you. The pin on your side is image pin. The pin whose image you will observe through the lens is called object pin. Is it clear? Many students are confused between the object pin and the image pin. So the object pin is that pin which you observe through the lens, and image pin is that pin which is on your side and which is used to detect the position of the image of the object pin. Just look at the diagram. This I dash is image of the object pin which this lens through refraction is forming here, and through parallax, when parallax is removed, the image pin and image both are at same position in the space. So image pin is that pin which is on your side and which is used to locate the position of the image, right? So here you use your common sense that if your pin is not up to sufficient height, then through lens how will you observe the inverted image? This is inverted image. Pay attention. You can remove the parallax between a real image and the image pin only. So the real image means inverted image. So the object pin should be at least up to the center point of the lens. Its height should be adjusted such. The second point, they are mentioning they are giving you instruction that keep the object pin at 0 centimeter. This will not affect the experiment, but when you are asked to calculate U, then whatever is the position of lens, you are supposed to subtract the position of object pin. If object pin is at 0, then you can easily understand that the calculation is simplified. Whatever is the position of the lens minus object pin's position, which is 0 here. So U can be calculated easily. And for the calculation of V, you have to subtract from the position of the image pin the position of the object pin. Right? So adjust the pins and the lens as given in the diagram. Keep the height of the object pin at least up to the center of the lens, and you will be at the image pin side and you will observe the inverted image of the pin. To find the inverted image of the pin, they are giving you instruction, and you also know that the distance between the lens and the pin, if it is more than focal length, then only you will observe the inverted image, that is the real image of the object pin. So let me go through the first instruction. Place object pin at 0 centimeter mark and the lens at 70 centimeter mark, so that object distance between the object and the lens is 70 centimeter. Now here let me clear you that the lens we were asked to prepare in the lab were of 10 centimeter length, focal length. So if this is 70 centimeter distance between the lens and the object pin, then you can easily understand that focal length of the lens is 10 centimeter and the center of curvature of the focal length or the radius of curvature of the focal length will be at 20 centimeter. So the object is beyond the center of curvature. Are you getting this point? Object is beyond the center of curvature. So you will here have a real inverted and smaller in size pin. And as you will move the object pin towards the lens, the size of the image pin will increase. So first you are supposed to keep the object pin at 0 and the lens at 70 centimeter. So we will mark this, that object pin should be 0 and the image pin lens should be at 70 centimeter. And then the process which they are telling you to remove the parallax, that we'll directly understand in the experiment. You can go through the instruction pausing the video. But what is the important thing is that ensure that parallax is removed. Tip to tip means if your image pin and image, they are not either tip to tip connected or they are overlapping each other, and say the image pin is like this, image is like this and image pin is a little displaced from the tip of the image, and you removed the parallax. In that case, if there is a little difference and parallax is not completely removed, you will not be able to detect that small parallax left in the case. That means you will be able to completely detect whether the parallax is completely removed or not when they are tip to tip connected. So that is why they are saying that the parallax, you check the parallax whether the parallax is removed or not by placing both image and image pin tip to tip, so that if there is a little position difference, what is parallax? When both the pins are at same position, then we say that parallax is removed. If parallax is left, that means the position of the two has a little difference. and in that case they will, when you will shift your head left and right, when you will move your head left and right, then there will be relative motion between the image and the image pin. There will be relative motion. So when it is tip to tip connected, then you will be confirmed that there is no relative motion and parallax is perfectly removed. But if it is not tip to tip connected and it is in this situation, then if there is relative motion, a little relative motion left in the situation, in the adjustment, then you will not be able to detect. So ensure that the image pin and image both are tip to tip connected when you confirmed that now the parallax is removed and we should take the readings. So parallax should be removed. This is the second instruction after placing object pin at 0 and lens at 70 centimeter. Obviously you will have the inverted image of the object pin because there is distance between these two more than 2f, that is, it is beyond, the object pin is beyond the center of curvature. So radius of curvature more than 2f distance. So you will have here the inverted image which will be smaller in size. Then you have to shift this pin, image pin, on the optical bench to find. You have to shift this image pin on the optical bench to find this position, because image is formed. If this is u, then for every u there is a specific V where the image will be formed according to the focal length of the lens. So just think of it that image pin's position is fixed. You have to find where is the image pin, where is the image position of image is fixed. So you have to find where the image is. So you have to shift this and you will not be able to see the image in a space here. Image is formed on this side between you and the lens. So to locate the position of image, you have to shift image pin on the optical bench forward and backward, keeping your head in the motion left and right, so that when there is no relative motion between these two and they are moving together in the field of view, then the image pin is exactly at the same place where the image is. So to locate it, you have to remove the parallax. This is the second instruction. So you have to remove the parallax connecting tip to tip, and when there is no parallax, then note the position of image pin and record the distance between image and the lens. So this is the second instruction. Note the position of the image pin. Mostly children don't write the position of the image pin, they directly subtract the position of the lens from position of image and they write V directly, but you are not supposed to write V directly. You first write the position of the image pin, position of the lens, position of the object pin, and then subtracting position of lens, position of object from the lens, get U, make a column, separate column for U, and subtracting position of lens from the position of image pin, get V, make the separate column for V in your observation table. Then the same process you have to repeat, keeping the lens at 60 centimeter from the object pin, 50 centimeter from the object pin, 40 centimeter from the object pin, and 30 centimeter from the object pin. Let the object pin remain at 0 so that we have direct U subtracting the position of from the position of lens 0. After calculating this, after performing the 5 times the experiment and having 5 set of observations, you are asked to calculate the quantities y and x. So you should have one column in observation table for position O. You will say it's 0, ma'am. Yes, every time you write 0 in that column. The position of lens, position of image pin, then one column for U, one column for V, and then one column for Y and one column for X. So total 3 plus 2 plus 2, that is 7 columns should be in your observation table. And then y is uv upon 100, that means centimeter into centimeter. So the unit of y should be centimeter square. I am mentioning once again that every column should have the quantities unit, otherwise you will be losing the marks. And x is centimeter plus centimeter, that is unit of x is centimeter. And next thing, first you have to repeat the experiment 4 more times, that means you should have 5 columns, 5 set of observation sets. Then calculate u, y, v, y and x up to 2 decimal places. So if you are not following this instruction, then your mark will be deducted. So the instructions should be underlined like I am underlining, right? Tabulate all 5 sets of observations, and then you have to plot the graph y versus x, and you have to calculate slope, and after getting slope up to 3 significant figures. And then you have to calculate focal length of the lens by using the formula slope into 10. And then you have to record your answer in your copy up to 1 decimal place with proper unit, that is centimeter. And one more thing, whatever readings you are taking from the meter scale, all the readings should be up to 1 decimal place, because least count of the meter scale is 0.1 centimeter. I many times in class 11th and in class 12th also I mentioned that your reading should be recorded according to the least count of the apparatus being used. So now let me switch to the optical bench and start our experiment. Now children, I have arranged the pins and lenses, and let me show you that the object pin is at 0 centimeter mark, and always use the side of the bench which you can read easily. This is the pointer, this line which is to read the reading, and at 70 centimeter mark this is 70 centimeter mark, the lens is placed right in the holder, and now this space is left for us to move this pin, which is image pin, and we have to observe from this side. So first I'll show you how the image of the object pin is viewed in the field of view of the lens, and then I'll show you the situation of the relative motion between the object pin and the image pin. Now you can see the inverted image of the pin in the lens class. This is inverted image of the object, and this is our image pin. Now we have to join the tip to tip, and that we can do by shifting the pin on the holder, on the stand. And now I will show that if you move your head left and right, can you see that both the pins are moving at different speed? Even if you join the tip to tip, they are having relative motion between them, and they are moving with different speed. Now I'll move this image pin on this position, on this space given to us or left for us, and I'll show how we have a position, specific position, and only that position, at that position, both the pins, image and image pin, both will move together, sticking tip to tip. So now we have to find that position by shifting the image pin left and right and keep moving our head left and right. Now just look at the motion of the image and image pin now. They are joined tip to tip so that we can have detection of even a small relative motion between them. And can you see that they are moving together in the field of view? This is known as parallax removal. At this moment, the position of image pin and position of image is exactly at the same place in the field of view. Let me focus so that you can observe the two pins clearly. So I think now you have a perfect idea of parallax removal, and that is achieved by just shifting the image pin on your side on the optical bench and keep your head moving left and right to check whether the position of parallax removal is achieved or not. And the parallax removal position is this: when the two pins, the image and the image pin, are moving together in the field of view of lens. So now we are going to note down the readings. So let me take the camera to the optical bench. And as I shown you earlier, this is 0, the object pen. This is the lens, and the position of lens is 70 centimeter, as we have already set. And check the position of parallax removal once again. This is something which I have to do to focus my camera on the two pins. Now since the lens was a little displaced from 70 centimeter, so can you see there is a little parallax? The two pins are having little parallax, and that we have to remove. We have to remove the parallax perfectly. So I will shift this image pin a little, and I'll keep checking whether the parallax is removed completely or not. So here is the parallax removal complete. Now the two pins do not have even a little parallax. If this little parallax is remains in the adjustment beta, then that appears in your graph, and your graph will not be correct, so the slope will be incorrect, and obviously the focal length will be incorrect. So let me see the position of image pin. or position of image also I can say. So lens is at 70 and the image pin is at 82, exactly at the 82. Here you have to be careful. Observe the reading from the top. This is 82. Yes. So let me note down the readings. So position of image is 82 centimeter. And now we have to set the lens at 60 and again we have to remove the parallax. Now let me keep the lens at 60. Object pin is at 0, lens is at 60 and again we have to remove the parallax by shifting the object pin in this region. And note down beta, as the distance between the lens and object pin is decreased, distance between the lens and image pin increases. That means as the U decreases, the V will increase. So we have to shift this pin by 111 millimeter. We have to shift it back to remove the parallax this time. Class, here is the parallax removal for 60 centimeter. I hope you can see that both the pins are moving together without any relative velocity between them. I want you to get it clear beta, so that the confusion which remains in the minds of a student what is parallax removal, that is being cleared. Right? So now we will take the reading of this position of the image. So let me this is 72.4. I hope you can see. So 72.4 is the reading now. And now I'll note down it in my observation table. Here is my observation table. And I have noted down 72.4. Now I am fixing my camera and I'll show you that for 50 centimeter how the parallax removal is being done. Now you have to observe me the way I am removing the parallax. First, I'll shift this lens to 50 centimeter mark. And I'll show you later that this is 50 centimeter mark. So I shifted my lens to 50 centimeter mark and now I'll show how to remove parallax. Observe my head movement, children. That is very, very important. We have to focus on the image and image pin. We'll keep the tip to tip connection and then just look at the way I'm shifting the pin and moving my head. Now I'm near to the removal of parallax beta, but I want you to observe my head movement. and the parallax is removed actually. But I confirm it by shifting the pins, image pin a little, 1 millimeter in forward direction and 1 millimeter in backward direction. I have to confirm that I don't get any position better than this. And just place yourself back and observe the two pins movement from a distance to get it cleared that yes, parallax is being removed. So parallax is removed, and now I'll take the camera to the observation optical bench so that you can observe first hand and can have a lab experience that what is the reading now. Now observe the value of position of lens, that is 50, and position of image pin. It is 63.2. So we will write 63.2 in our observation table. So I'll take camera to my observation table, and it is 63.2. And now I'll again shift my lens to 40 centimeter. So we started from 70, 60, 50 and now 40. Now lens is at 40 centimeter. Right? And again I am fixing my camera so that you can observe the way we have to remove parallax. You have to sit properly at the level of the lens and then move the image pin. Keep moving your head also. And parallax is removed. Actually, if practice is good, the parallax removal is of few seconds work. And then place your head at sufficient distance and cross check that parallax is removed, and yes, parallax is perfectly removed. So again I'll show you the readings. And observe now the image pin is at 54.4. 54.5 in fact. 54.4 and 5, in between 54.4 and 5. So we will take 54.4. And now we will write it in our observation table. This is 54.4. And now I'll place my lens at 30. And I want you to see properly the head movement and the way we have to find the exact position when the parallax is being removed. Children, just focus on the head movement. And my focus is completely on the two pins, and I ensure that the two pins are having tip-to-tip connection. And the parallax is removed. You can see yourself that it is even 1 or 2 seconds work. And once you remove the parallax, then please place your head little back and get it confirmed, because if there is relative motion between the two, little bit, then you can detect it properly when you are observing the two pins from distance. Yes, parallax is perfectly removed. And as we are going closer, the lens is going closer to the object pin, the image of the object pin is increasing in size. And at this time it's 30 centimeter, at a distance of 30 centimeter. So you can easily understand that since the focal length of the lens is 10 centimeter, so still it is beyond the center of curvature. So now let me show you the reading, the new reading. This is the final reading for us, and after that we will start our calculation. So now check yourself, the reading is 46.2. So let me write it. So our experiment is complete. It is 46.2 centimeter. Our experiment is complete, and now we will start calculating. Now it's time to complete our calculation and then draw the graph. So in your observation, in your practical copy, examination copy, you will mention the question number, and then under the heading of observation, the first observation should be the least count of the apparatus used. After that, just check that all the readings taken from this apparatus is in sync with the least count, that is up to 1 decimal place. So positions you are taking from the meter scale. So if you are writing 0, then write 0.0, 70.0 up to 1 decimal place, right? And then position of image 82.0, 72.4 and 63.2, they are already in the decimal, but where the decimal, first place of decimal, there is no number. Children forget to mention the least count. After that you have to calculate u, and that you have to calculate from by subtracting the value of position of object pin from the position of lens. So here I have calculated all the readings. After that, position of image pin, from position of image pin subtract position of lens, and you will have the V, that is distance of image pin from the lens. Now you can see that if U are decreasing, then V is increasing. This pattern should be, if this is in decreasing order, then your V should be in increasing order. It should be in increasing order. This pattern should be correct, because 1 mark is allotted to this pattern, whether the child is getting pattern correctly or not. So just observe the pattern here. Always when U will decrease, the V will increase. And after that, X and Y we are supposed to calculate using the formula given, and this is U plus V upon 10 and UV upon 100. So I have calculated, and look at the way I represented the values. I have shown the calculation there. You can take more space in the column, but show the calculation. And then the values I have underlined so that examiner can easily detect which values I have plotted on the graph. So this is your observation table. See it carefully. All the units are written at their proper place. Then least count is taken care. And then calculation is being shown. So observation table is completely correct. Now come to the graph part. Now in the graph, the first thing you draw x-axis and y-axis, and then mention that x equal to u plus v upon 10, that is which you are plotting here in centimeters. and on y-axis you are plotting y is equal to uv upon 100 and in centimeter square. So just check that the unit should be correct everywhere. After that, I want to give you one more instruction which is very important. In the question paper, you were not asked to take the origin at 0, 0. Secondly, there was nothing which you have to read, no quantity you are supposed to read from the graph. If these two conditions are there, either in the question paper, they are mentioning that take the origin as 0, 0, or they are asking read a particular quantity from the graph. In these two conditions, you have to take the origin at 0, 0. Otherwise, we can take origin any coordinate, like here I have taken 4, 4 as the origin of my graph. So, why I have taken 4, 4 as the origin of my graph? Because my readings, you have to see the readings. You are supposed to plot 4.62 to 8.20 on x-axis and 4.86 to 8.44 on y-axis. So, if I take 0, 0 as my origin, then from 0 to 4, this much part of the graph will be completely empty. It will not be used. While the instruction of board is that you have to use 60% of the graph paper. That means the scale taken should be as large as possible because it increases the sensitivity of the graph. So I have taken 4, 4 as the origin, and now let me tell you, at 20 small divisions I have taken 5. So after every 20 divisions I increase the 1 unit. Right? So that way I was able to take the 9 unit up to 9 centimeter on the x-axis, and in similar way I have taken 20 divisions. This is starting from 4, 5, 6, 7, 8 and 9. So I have mentioned, this is again very important, you have to mention a scale there. I have mentioned that 20 small divisions are equal to 1 unit on y-axis as well as on x-axis. After mentioning it, I have to see that what is my scale and what is the value of 1 division of my scale. So the scale I have taken that facilitates me that if 20 divisions are equal to 1 unit, just see, 20 divisions are equal to 1 unit, then 1 division will be equal to 1 upon 20, that is 0.05 unit. So this tells me that if I move to first small division, then it is 4.05. Next it will be 4.1. Every small division will add 0.05 to the previous value. So here it is 4.05. You just observe how we read the graph. According to our scale, this is 4.05, then 4.1, 4.15, 4.2, 4.25, 4.3, 4.35, 4.4, 4.45, 4.5 and so on. So each small division is reading 0.05 according to the scale we have taken, and 2 divisions together will read 0.1. So now we are ready to plot the graph, and just look at the readings. We have to plot x and y. So I am just taking the x and y in my picture. Check out the first reading. It is 4.62 on x-axis and 4.86 on y-axis. So, sensitivity of graph is when we can plot up to second decimal place, which we have taken in the observation, and we have taken the scale also enough large that we can plot the second decimal place. But just look at the 4.62. We can take 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, and after that we can have 4.65, but we are supposed to plot 4.62. So 4.65 either we can plot or we can plot 4.60. So 4.60 is closer to the value we have. So we will plot here 4.1, 2, 3, 4, 5, 6. We will plot 4.6 on x-axis instead of 4.65. So keep your scale like this, and here is 4.6. Now 4.86. Now here either we can plot 4.80 or we can plot 4.85. So 4.85 is closer to the reading instead of 4.80. So we will plot 4.86. This is the way we have to plot the graph to make our graph more sensitive and accurate as is possible. So this is 4. You know that we have taken origin y-axis and x-axis 4, 4. So 4.1, 4.2, 4.3, 4.4, 4.5, 4.5, 4.6, 4.7, 4.8 and 4.85. So this is our point. The same way I have plotted 5.44, 5.44 and 5.76. This is 5.44 and 5.76. Next is, so actually I have plotted 5.45 because I cannot plot 5.44. I can plot either 5.40 or 5.45. So I have plotted 5.45 and here I have plotted 5.75. Similarly, I have plotted 7.25 and 7.45. This is This is 7.45, 7.25 and 7.45. I have plotted 6.30 and 6.50. This is 6.30 and 6.60, right? And the last reading is 8.2 and 8.4. So that was easy to plot. So that way we got 1, 2, 3, 4 and 5 readings, 5 observations. Now comes the very important part, that is best fit line. Best fit line means either 3 out of 5 observations lie on your line, or the line is representing average value of the observations. So if I have taken these 3 lines, 3 points in my line, then these 2 points have been left to the right side of the line. That is not right. If I have taken these 2 points in my consideration, these 2 points, then 1, 2 and 3 on the left side. So I joined this point and this point. That way, see, this is little shifted towards right, this is little shifted towards left, and this also little shifted towards left. So 2 towards left and 1 towards right. So that way, although only 2 points are on the line, but the line is representing the average value, 2 on the left and 1 on the right, and the left points are very close to the line. So this is called best fit line. So now you can see the graph. And after that they said that calculate the slope. So the rule is that you will not use any of the observation point for the slope calculation, and the 2 points which you will calculate, which you will take to calculate slope, should be random and should be far apart. So I have taken this point and this point, which can be read easily from the graph, and I have dropped perpendicular on this and this axis. So you can see that after dropping the perpendicular, I can read x1 and y1 from the graph according to our scale. Similarly, I have taken one point here and I dropped perpendicular on x and y axis, and now I can read x2 and y2. Now the part of calculation. So next, after observation, the next heading will be calculation, and you will write the formula for slope y2 minus y1 upon x2 minus x1. Then, as I have shown, I have already written on the graph, mentioned on the graph y2 and y1, x2 and x1. So I just substituted the values and I got, they have written up to 3 significant figures the slope should be calculated. That means there should be, if it is easy to find the number of significant figures, if you call that number, if you try to read that number, and you can read only significant numbers at one go. So 983, that means 3 significant figures. This is not a scientific method, this is a trick to know the number of significant figures in a number. So 3 significant figures they ask you in the question paper. So we have written the slope with 3 significant figure and the unit. Always remember that except sometime the slope always has a unit. After that they said that focal length is slope into 10. So we calculated and we got 9.83. And as I told you that the focal length of our convex lens is 10. So our reading is within 30%. 30% error is allowed, within 30% error. So the result is that given focal length is 9.80. So this is how you have to write your question answer paper or in practical exam. Pause the video and observe every minute detail to get perfect 15 in your practical exam. And I have demonstrated you the whole experiment, and I hope you have the lab experience here.